Yo, 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 yo. Yo, 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 yo. All right, everybody. So we're going to talk about the volume of a sphere. So here are our key terms, which is just the formula for the volume of a sphere. So volume of a sphere is a lot different. We're still using the radius, but a sphere is basically like a basketball, a volleyball, the same type of ball, is a sphere, globe. Okay, so what we do is we do 4/3 pi r to the third power. That is a cubed, not square. So this formula is definitely different than a cylinder and a cone. Now, the 4/3 can throw some people off. So I'm going to show some strategies on how to work with 4/3. But let's just get right into it. So if I'm looking at a sphere here, and I want to find the volume of it, we're going to round our answer to the nearest tenth. So I'm going to plug the value into my formula, which again is 4/3 pi r to the third power. So first, I have 2.1 is my radius because it only goes halfway into the sphere. So I can plug in 2.1 in for radius, and that's 4/3 pi. Now, 4/3 is the same thing as multiplying by 4 and also dividing by 3. So it's the same thing as multiplying by 4 and dividing by 3. So here's how we're going to play this. Here's how we're going to do. First, we always cube the radius first, kind of like with cones and cylinders where we square the radius first. We're always going to cube this first. So I need to do 2.1, not times 3, but I'm doing 2.1 times itself 3 different times. So I went 2.1 times 2.1 times 2.1, and I just plugged it into a calculator. I get 9.261. Okay. So I did 2.1 times 2.1, and then I also multiplied by 2.1 again. So now I've got 4/3 times pi times 9.261. So here's what I'm going to do with this value. I'm going to work with the 4/3 now. I'm going to multiply this value by 4. And then I'm going to divide by 3. So if I multiply this value by 4, I get 37.044. So here's what I did. It's because, again, this is just 4/3. So if I multiply by 4, I still have the over 3 left, which is divided by 3. So when I multiply this by 4, I'm left with 37.044. And now I just get to divide that by 3 because that's our same thing as times 1/3. So that's the value that I'm going to divide by 3. I'm going to combine this and divide this by 3, and that's going to give me 12.348 times pi. Okay, so what we do is we cube our radius, and then I just multiply that by 4 and then divide by 3, and then now I get to multiply by pi. Notice I haven't rounded any numbers yet. I still have a lot of numbers after my decimal. When I multiply this by pi, I get 38.77272. None of this extra really matters because I want to round to the nearest tenth. Well, nearest tenth, now that I'm done with the problem, now I can round. My nearest tenth is saying, let's round this number, so I got to look at the one afterwards. That's going to be 38.8. And I'm done. Oh, I forgot. Centimeters cubed because it's volume. Okay, so recap, the way we deal with the 4/3 is we treat it as times 4 and divided by 3. Another way you can even write the formula, and this might even help, 4 pi r cubed divided by 3. That helps because I'm just multiplying these and I'm going to divide by 3 at some point. Very similar to a cone. I can even write it as 1/3 times pi times 4 times my radius cubed. All of this, it means the same thing. Okay, so I can even do it like this as well. So I can do radius cubed times 4 times pi divided by 3 at some point and go that route. Okay, so just try B on your own. So see if you can use your formula. I'm going to erase all this, but see if you can use your formula. Try B. This is your diameter, so we need to change it to our radius first, and then we get to go from there. So try it out, see what happens. Okay, so again, 4/3 pi r to the third power. My radius is going to be 3.5 because that's half of 7. So that's 4 times pi times 3.5 to the third power. And I eventually got to also divide by 3. Well, let's do my 3.5 to the third power And that gives me 42.875. I know I got to multiply that by 4, multiply that by pi, and then I also got to divide by 3. So I can times it by 1/3. I'm writing the divide by 3 differently on purpose to show you how there's different ways we can look at it to see which way works for us. So I'm going to take that 42.875. I'm going to multiply that by 4. That gives me 171.5 pi times 1/3, because we know the 1/3 is divided by 3. So now I can divide by 3. That gives me 57.166, and it just keeps going and going and going. And that's times pi. Whoops. And that's times pi. So now I get to take that value and multiply it by 3.14 without, I haven't rounded anything yet. And I get 179.503. Round to the nearest tenth. That 0 makes it stay the same. So it's approximately 179.5. And this one's also centimeters cubed. Cool. So same process. We get to do everything in almost any order we want as long as we cube our radius first, and then it says using our calculator to multiply by 4 and divide by 3, and that's how we handle that 4/3. Okay. So another one that I want you to try. Here we have soccer balls come in several different sizes. One soccer ball has a diameter of 22 centimeters. So that's a diameter of 22 centimeters. What is the volume? We want to round our answer to the nearest tenth. So go ahead and try this one on your own. Pause it, try it, see how you do. Okay, so here's your answer. Volume. I have my formula. I plugged in my radius because it's 11. That's what I got when I cubed it. I multiplied by 4. Divided by 3, times it by pi, and then I rounded, and there's my final answer. We might also have to go backwards, and we might have to be given the volume, and we have to find the diameter. So we're going to look at an example of that right now. So I'm still going to use my formula, which is 4/3 pi r cubed. I'm going to plug in the values that I know. I don't know the radius because it's asking me for the diameter, but if I'm given the radius, I should be able to easily find the diameter. So I'm really trying to solve for the radius. But I know the volume. The volume is 288 times pi. So that's equal to 4/3 times pi times radius cubed. Well, here's the nice part about when I have pi on both sides. If I want to cancel out that pi, I can just divide by pi. That's now gone. So now what I'm left with is 288 equals 4/3 times radius cubed. So there's a couple ways to look at doing this. One way is I can just flip this fraction and multiply, which is by 3/4. Or, because we're also looking at it as times 4 divided by 3, the opposite of times 4 and divided by 3 is times 3 divided by 4. So if I want to cancel out this divided by 3, if I multiply by 3, that goes away. But whatever I do on one side, I have to do on the other side. So I'm doing 288 times 3, which is 864. The 4 is still there. So now this is where I can divide both sides by 4. And I'm left with 216 equals my radius cubed. So now that I've got my radius cubed, I need to figure out, well, what times itself 3 times is equal to 216. This is when we do that cube root. So if I want to cancel out to the 3rd power, I take the cube root, which is what times itself 3 times is equal to 216. Okay, so now for that, the answer is, I believe, 6. I'm just checking with my calculator. It is 6. So the radius is 6, which means I can double it, and the diameter is 12. So to figure out what the cube root, some calculators can do it, some cannot. If a calculator cannot do it, then what we need to do is, it might be like a quick guess and check. And so you might want to do 5 to the 3rd power, or 4 to the 3rd power, see where you're at, and then go from there. Okay, or we might have a list of perfect cubes somewhere, and then that might make it a lot easier as well. So yeah, so diameter is 12 because my radius was 6, and I'm all done. All right, guys, that is all. So things to remember: 4/3 equals times 4 and divided by 3. Okay, let's do this independent practice. Make sure you show all your work, and that's all I got for you guys. So thank you for watching, and I hope this helped. Critias out.